Let's say you've written some really cool Python code and you want to share it with your friends and colleagues. Then you need to prepare it, package it up. And that's really what I'm going to talk about today, is how you take your code and turn it from the Python files on your computer into something other people can use and install. My name is Yngve. I'm a data science consultant for Bouvet. And this talk is really structured in 3 pieces. I'll start by trying to give you a brief overview of what packaging is and some tools that we use for it. And then we'll compare these tools a bit more in depth before we'll have time for a little demo in the end. So let's start with the introduction. As I mentioned, packaging is all about taking your code and turning it into something someone can install. And there's really 2 types of packaging. You've got application packaging. That's when you've got like PowerPoint or Photoshop, and you want to make that installable for someone else. Then you use PyInstaller or Briefcase or something like that. And then you've got library packaging, which is when you've written not an application, but a software library, and you want others to be able to use that as a dependency in their scripts, in their applications, or in their libraries. And I want to focus on library packaging today. And the easiest way to do it is just collect your scripts in a folder, but add a requirements file where you type down, you need these different libraries installed to use my code. And it sort of works, but it's not ideal. There has to be a better way, and there is. It's called package managers, like pip and conda. Pip is a pure Python package manager. It deals with Python dependencies. And conda is often compared to pip, but I think that's kind of unfair, because they solve vastly different problems. Conda deals with general dependencies and general environments on your system, while pip deals with Python dependencies. So let's say you got lots of videos of your dog, and you want to edit those with Python. You're going to need Python and your Python dependencies, but you're probably also going to need FFmpeg, which is an open source video editing program and library that you can script. FFmpeg is not a Python dependency, so it's kind of difficult to handle FFmpeg with pip, while conda does it in a nice way. Still, that doesn't mean that conda is any better than pip. If you don't need these extra bells and whistles in conda, you should probably use pip. It's very simple to understand and use. So to understand packaging better, let's go and have a look at how pip installs a package. You want to install, say, the web framework Lightstar. You write pip install Lightstar. Pip will then go to the Python package index, search for Lightstar, and download metadata about Lightstar. It will then start installing dependencies. So you have everything you need to install and run Lightstar before it downloads the package itself. This is either a wheel or a source distribution. The difference is kind of technical, but the idea is it's an archive, like a zip file, that has your source code and some machine-readable instructions on how to install it. Pip will then extract that to the site packages directory on your machine, and it's installed. Now, the key question is, how do we create the wheels and the source distributions? And I want to focus on this question today. There's a lot of different tools for it. So let's start going through them. We've got setuptools. That's the first I'll mention. It's an improvement of the built-in distutils, which is now deprecated and removed in Python 3.12. And it can do pretty much anything, but it can do anything in like 5 different ways. And it's not always easy to know how should I do it and how should I do it in 2023. So to get around that, a few years ago, there started popping up other packaging tools that had just one way to do it. It was very simple, like flit. It deals with most use cases, but not all of them. and in a very easy way. But often when we're developing, we want more than just creating the wheel. So sort of project management tools like Poetry came into picture. Now, Poetry deals with a lot more than just packaging. It also deals with dependencies and virtual environments and all of these useful features. But I've just picked out 3 tools here. And each of them had their own way of solving the same problem, their own way of storing the same information, storing the project metadata. So you got this great standard. The steering council decided on PEP 621. This is how we should store information about our packages. This is the author, the name of the package, the dependencies. All of this information now has a standardized way of how it should be stored in the pyproject.toml file. And there's a couple of other standards that I want to briefly mention. It's PEP 517 and PEP 518. This is a bit more technical, but it deals with the build backend and the build system and build dependencies. Now, to understand what this is, since we're in Stockholm, I'll use the official Swedish language, IKEA instruction manuals. A build dependency is a screwdriver you need to construct this beautiful Rodulf sit and stand desk. You don't need the screwdriver to use it, but you need to build it. So the screwdriver is part of the build system. And that's dealt with by PEP 517 and 518. PEP 621 deal with the library itself. To use this sit stand desk, you need electricity. So that's a library dependency, and that's handled by PEP 621. These standards are great and makes tools a lot more interoperable, and they've largely been adopted. A notable exception is Poetry, which at least now has not adopted the latest PEP 621 because their way of doing it clashes, so hopefully they'll sort it out in a future major version release, but at least for now, they don't. We've also got a couple of newcomers, Hatch and PDM, that definitely follow the standard. So what should you choose? Well, let's compare them a bit more systematically. First off, the standard, everything except Poetry satisfies the standard. This is really useful to avoid vendor lock-in. So easy to switch between different tools that have the same representation of configuration. Then C extensions. Imagine you want to write a really fast library like NumPy or SciPy or PyTorch. You can't have all the code in Python. So you'd probably write some code in C, C++, Rust, or Fortran. Then you're writing a C extension because you're extending the CPython interpreter, and most tools here support that to some extent. Setuptools definitely has support for it. Flit didn't by design. They wanted to cover most use cases, but not all. Poetry has undocumented support for C extensions through something they call the build.py file. I believe it's similar to the setup.py file in setuptools. I'm not sure. If you need it, you can read about it in some GitHub issues. PDM has an absolutely stellar way of handling this, and I'll talk a bit more about that in a second. And Hatch, while not natively supporting C extensions, it does have this really neat plugin system where you can extend the build system and add support for Python or Rust or whatever. And you can use plugins that someone else have made as well. Next thing is a clear separation of the build frontend and the build backend. The build frontend is what we use when we're typing PDM add a dependency, Poetry publish. That's the build frontend. And the build backend is the piece of code that does the one thing of turning your library into a wheel or a source distribution. Typically, you use the same tool for the front end and the back end. But imagine you're starting developing something. You think you just need Python. And then you realize later on, oh no, I actually want to write this one piece of code in C++. Then if you're using PDM, you could switch out just the build backend with any standard compliant build backend. Next up is dependency management. When you're creating a library, you want to make sure dependencies are compatible. So let's say you have two dependencies, dependency A and dependency B. Dependency A needs Pydantic version 2, and dependency B needs Pydantic version 1. These two cannot coexist in the same project. So you'd like a build system that tells you that, hey, you can't have these two. And currently, only PDM and Poetry will do dependency resolution this way. They've also got something called lock files, which are essentially just a text file with every installed package in your environment, with a hash and everything. Makes it very easy to create reproducible environments, so multiple developers can sit in the same environment, and you're also using that environment when you deploy it to production, for example. Next, environment management. I've already mentioned virtual environments, but let's take a step back. A virtual environment is just essentially a Python installation for each of your projects. There are many reasons to use them. One of them is you might have two different projects with clashing dependencies. You have one where you're using Pydantic version 2 and another where you're using Pydantic version 1. You can't have those two versions installed in the same environment, so you're using separate virtual environments for each project you have, and Hatch, PDM, and Poetry can manage these environments for you. Hatch takes this one step further with what they call an environment matrix. You specify, I want my code to run on Python 3.10, 3.11, 3.12. I want it to work with and without these dependencies. And Hatch can set up all of these different combinations and run your unit tests in all of them. If you're not using Hatch, you would use something like Nox or Tox, or you'd maybe set it up in your CI/CD system instead. Finally, more than one developer. These are all open source tools, and we don't want mission critical code that we're writing to stop working because an open source developer who's devoting their own spare time for free loses interest, or maybe they're not able to focus on it anymore. Unfortunately, only Poetry and setuptools has, as far as I can tell, more than one developer who's contributed a significant number of code lines. Luckily, with the standard, it's very simple to switch between different standard compliant build systems, and especially if you have the separation of a build frontend and build backend that PDM has. You could switch at one but not the other. Now, this is just the set of features that I thought was the most interesting for most of you in most use cases. But there's a lot of other things to cover as well. And you might think, oh boy, what should I use? Pretty much any of these tools will serve your need, especially if you're using one of the more modern tools. I've used Poetry a lot in my professional life, and it's really nice. But my personal favorite is PDM. PDM feels very similar to Poetry, but a bit more polished. And it follows a standard. And it's just so easy to use. And that's actually what I want to show you guys now, is how easy it is to start with absolutely nothing and create a package and then publish that package on PyPI so anyone else in the entire world can install it in a second. The first thing you do is you create a directory for your project. You navigate to it and you run the PDM init wizard. You're asked a couple of questions. Which interpreter should you use? What's the author? What's the name of the package? Which build backend? And all of these have same default values. And then you would install this new project in a virtual environment managed by PDM. So let's have a look at what files we've got. We have the .venv directory. That's where the virtual environment lives. We have the source directory with the code, the tests directory, a PyProject.toml file with project metadata, and a README file. We can now start coding. So let's code up a small little script that just gets the weather forecast for Stockholm for the next 8 hours, and then plots that in the terminal. To get the weather forecast, we need HTTPX to do the web requests. And to plot, we use plotil for the terminal plot. So you need to add these dependencies, pdm add HTTPX plotil. And now pdm will make sure that one, these packages you're adding are compatible, and two, that you have these two packages installed in the virtual environment managed by pdm. So now we can just run the code, and we want to run it in the environment managed by pdm. So you write pdm run Python, and then the script. We get the nice plot we want out, and we can upload this to PyPI. We write pdm publish. This is where we have the build backend. This is the only thing the build backend does. You see, it says building Estes, building wheel. And then we type in our username and password. I'm using a token here. And it's uploaded to PyPI. Now, all of you, if you just type pip install PyCon SC23 demo, you will get Python code to get the weather forecast for Stockholm for the next 8 hours plotted in your terminal. It's really that simple. So if any of you are hooked on packaging and want to read more, then here are some absolutely stellar resources that I used preparing for this talk, especially the top guide, the PyOpenSci guide for packaging, and also the Python packaging user guide. There's absolutely great resources. The PyOpenSci is not at all just science related. It's relevant for anyone who's doing packaging. I'd also like to recommend the QuantSci article that I read today about how SciPy really struggled with Python 3.12. It's an interesting read. I'm going to end this by thanking Bouvet for letting me spend time on this presentation, and my partner Marie for helping me with the slides and coaching me through presenting. So, to summarize, packaging is just a task of taking your code and preparing it to be used by others. And with PDM, it's really simple. Thank you.
Thank you so much. Do we have any questions? Way over there. Could you pass this back?
How well does this work with like private repositories, like with if you have a private Artifactory?
It uses Twine, PDM uses Twine behind the scenes, I think. So you could just set up your repo with a PyPI RC file.
Hello, thank you for the presentation. Really interesting to see about all these packaging tools. I'm used to use Hatch, but one thing I struggle with usually is to manage versioning. I like to have a command that can automatically bump the version and optionally make a git tag. Does PDM has a way to solve this?
That's a very good question. I think it does. I've only used it for hobby projects. I haven't gotten into looking at dynamic things, but I believe so. Yes. It is written by, PDM is written by one of the people behind the standard and is following the standard pretty well. And in the standard, it also specifies how, like, that's one of the big benefits with the standard compared to poetry, for example. If you have dynamic versions in poetry, you're switching out the build system with this dynamic versioning build system. But then there's no clear way to signify that the version is dynamic. And in PEP 621, it says any dynamic key should be specified as version equal dynamic. And then the tools will put it in, and you'll get error messages if it's not handled in the correct way.
Thank you.
Yes, thank you for the talk. I wonder, because you mentioned that the PDM is really good at managing the version dependencies, the different versions between the dependencies. How well it is at managing between different Python versions?
I don't know if you, it was just very brief there in the animation, but you get prompted when you're answering the, if you see here, on the top there you see you need to specify which Python interpreter you want to use. And then it will use that to create the virtual environment. And one thing I tested this morning was what happens if I have, if I'm pulling something from GitHub or something, and then I set, my default selected interpreter is not the one required by the project, and I got the message, your current interpreter is not correct, trying to find like an appropriate interpreter for you. So that's one of the really major issues I've had with Poetry, is how it will tell you you're using Python 3.11, but you are in fact using Python 3.10, for example. And it's a really terrible bug, especially when you're onboarding beginners, to try to figure out what's wrong, because it says there, oh, it's a 3.12 environment, but it's using Python 3.8, for example.
Hi. You mentioned that there is support for C extensions in PDM, but in practice, how realistic is it? Because typically when you're dealing with C extensions, you have to provide library paths, extra include files, and...
So what you can do with PDM is, because you have this clear separation of the build frontend and build backend, you could use a tool like Mason, which is what SciPy uses. Mason is standard compliant, so you could use Mason as your build system with PDM as the front end. So then you might have power users who know how to deal with all the build backend, but then you have a lot of Python wrappers as well that you don't need experts to deal with, and that your average developer on the team can manage that. So you don't actually need to use Mason until you need to, essentially.
Is it well documented how to use Mason along with PDM?
Yes, it's... Now, unfortunately, this is a video, so I can't show you, right? Yeah. But in the standard, it says, for the build system, you write down what build system you should use and what the entry point to that build system. And you just switch that out. So you just follow PEP. I never remember 5.18 or 5.17. You just specify your build backend according to one of those two. And as long as it implements the interface defined by the same standard, that's the build system used.
Thank you.
Anyone else? I have one question, and that's one thing that's always been an issue ever since DistUtils is packaging package data or data files together with your code. Do you have an opinion on which of these tools do that best or less worse?
No, I don't. But yes, I know it's a problem. Okay, I think, yeah, then that's good. That's it for me, I think. Unless there's any more questions.
Thank you.